Okay, number 16, we have a word problem that involves a mixture. So these kind of problems you'll see come up, quite often. There's definitely some problems in homework that deal with this. So let's take a look and walk through. Now these kind of problems that deal with these mixtures and has a lot of information in it, I like to set up a table for these because it helps to organize all the information better, and it's going to help you actually come up with the equations for this. So chemist mixes some 70% solution and 40% to obtain 120 gallons of a 50%. So we need to figure out a way to organize all this information so we can come up with the equations for it. So we have percent solutions, we have different types of gallons. So let's go ahead and we're going to set up, first of all, I'm going to do a solution. This tells you which particular one that you're working with. We also have some gallons that are there, so we want to set up a column that deals with the gallons since they're giving us that information. And then we're going to do what's referred to as concentration. So that means this is actually what we're going to take the percent and turn it into a decimal here. And then what we'll do is the end is going to be the total amount that you have of each one. So this is just a labeling system here, but what we're going to eventually do is we're going to take the gallons, we're going to multiply it by the concentration, and that's going to equal a total. So that's why I'm kind of setting it up this way. So first of all, the first solution that we have here is a 70% solution. So I'm going to go ahead and put that in right here. What else do we have? We also have a 40% solution, and then the last one here is 50% solution. So we're going to first start by this because we've got that's the three different solutions that we're given. Now concentration, we can actually just take these percentages and turn them into decimals, and I can just automatically fill out that concentration column. So 70% is a decimal. I can write that as 0.7, and then I can write this as 0.4. So when you're taking the percent into a decimal, you're always moving the decimal place 2 places over to the left. So percent sign goes away, move it 2 places over. That's how we're getting these decimals here. So 50, you move that over 2 places, that's going to be 0.5. Okay, so we got that complete. Now, here's where the algebra comes in. We want to come up with algebraic expressions for the gallons. Now, it's not telling us how much that we have, but we do know that there's 120 gallons of 50% solution, so that's the only one we know for sure that we can put that there, 120. Now the other ones, I'm going to label this, I'll label one of them as X because I don't know how much I have. So now we have to come up with an expression for the 40%. Now, this has to add up to 120. If I have, let's say I have 120 gallons and I use up 40 gallons, then how much should be left over? Well, you would take 120, subtract 40 to get 80. So that kind of thinking you can use here to find out how much is left over. So I have X amount, the rest of it must be 120 minus X. So if I were to add these two things together, it would add back up to the total 120 that I have. So this is the expressions I'm going to use for each one. Now, I'm going to take the gallons, multiply it by concentration, and that's going to give me the expression for the total. So I'm just going to multiply that together. So 0.7x I'll get for that one. I get 0.4 times 120 minus x, and I'm going to multiply that out later. Just going to go ahead and leave it like that. And then I'm going to do 120 times 0.5. So that's my 3 algebraic expressions that I have. Now the way the mixture problems work is you're mixing these two together. You're mixing the 40% and 70% together to get the 50%. So that means that if I take these two expressions and add them together, it should be equal to this bottom one, 120 times 0.5. And that, in fact, is where I'm going to get my equation from. So let's go ahead and write that out. I have 0.7x plus 0.4 times 120 minus x. And then that's going to equal 120 times 0.5. So that's my exact equation I'm going to use to solve for this. So 0.7x plus 0.4 times these two mixtures together, added together to equal this one. So now it's just a matter of multiplying it out and simplifying. So I get 0.7x here, and then I'm going to multiply this one out. So when I multiply that one out, I'm going to get 48 minus 0.4x, and 120 times 0.5, I get 60. So I want to multiply that out to clear out the fractions and simplify it so I can get something I can solve for. Okay, so now what I have to do is I'm going to make some space up here. I'm going to leave the table there for you. Let me go ahead and continue the problem up above there since you already have that written down. Okay, so now we're going to go ahead and do some more simplifying. I have like terms here, 0.7x and minus 0.4x. That's going to give me 0.3x. So positive 0.3x I get for that one. I still have the 48, and then that's going to equal 60. I just add the like terms together. I'm going to subtract 48 from both sides. So subtract 48, do opposite operation on that one. So 0.3x is going to equal 12. I want to divide both sides by 0.3 because I want to get the x by itself. So if I divide both sides by 0.3, then what my final answer is 40. So I get 40 gallons for x. Now when I write my answer in, that's going to go with the 70% because I said that x was equal to 70%. So that's why I'm writing that up there. So this right here is for the 70%. Now, since I know that it has to add up to 120, I'm just going to take 120, subtract 40, and I'll get, the other one, x is 40 gallons, but I also know that if I subtract it from there, then I get 80 left over, so 80 gallons. This is going to be what I have for the 40%, because originally the question asked how much of each do you have. So my x was this one, 120 minus x gives me this expression right here. That would be your 40%. So that's how much of each that you're going to need.